matters.
We have the distinct pleasure to hear from Dr. Jill Tarter, who is the Bernard Oliver Chair at the SETI Research Institute. Dr. Tarter also is a co-founder of the SETI Research Institute in Mountain View, California. She has her PhD in astronomy from the University of California, and she's done just about everything you can think about, and she has incredible credentials. She is one of the reasons that we probably still pay so much attention to and think about in a realistic fashion the whole science going beyond our solar system and thinking about establishing things beyond our solar system. And I'd like to have Dr. Jill Tarter talk about SETI, exoplanets, and Kepler.
Thank you so much, May. So my question is, where are we going? Humans, for many millennia, humans have been on a journey seeking answers to questions about who we are, why we are, where we're going, whether there's anybody else out there. Since 1968, we've been able to envision ourselves here. And the Cassini spacecraft looked homeward and was able to see ourselves here through its rings, or through Saturn's rings. Our journey has brought us to the realization that our star is only one of 400 billion stars in the Milky Way galaxy, and that our galaxy is only one of about 100 billion galaxies in the observable universe. Now remember, that's only 4% of the total mass energy density of the universe. Furthermore, this journey has helped us to discover our intimate connection to the cosmos. So the lessons that we now pass on to our students and to our children and to all earthlings is that we are made of stardust. The iron atoms in the hemoglobin molecules of our blood were fused deep within a massive star that ended its life about 8 billion years ago in a spectacular explosion, leaving a remnant such as this modern one. And those remnants were and continue to be incorporated into new generations of stars and planets and perhaps life. You know, those of us in this room are really, really very privileged. And one of those privileges is that we are among the very first generation to be able to comprehend that we live on a fragile island of life in a universe of possibilities. So extremophiles like these are now illuminating the amazing possibilities for life on our own planet and suggesting that there may be more potentially habitable real estate for life as we know it and life as we don't yet know it out there in the cosmos. So our journey is taking us further into space to find answers to our questions. We're now looking for conditions that might support life on Mars, now or in the past or in some potential future colony. And before long, we'll begin to explore the watery oceans beneath the ice on Jupiter's giant moons, Europa, Callisto, Ganymede, and the ethane lakes on the surface of Saturn's large moon, Titan. We're looking for evidence of a second Genesis, and we may have to look beyond our own planetary system. You know, until 1995, we didn't know about any planets orbiting any other stars. Now we do. In fact, it's probably going to turn out that there are more planets out there than stars. Since March of 2009, a small spacecraft called Kepler has been enormously successful in detecting the tiny changes in the brightness of stars as planets transit in front of them, blocking a tiny bit of the star's light for hours at a time. In a single 100 square degree patch on the sky, Kepler uses a 93 megapixel CCD camera to stare continuously at 100,000 stars, for some of them to blink. And they do. Kepler has now found 2,740 planetary candidates. And ground-based astronomers have had time to follow up on about 105 of them, confirming that they are real planets. And the expectation is at least 90% of the remaining candidates will turn out to be true planets, and some of which may be just right for our kind of life that requires liquid water. 58 of the Kepler candidates are located within the habitable or Goldilocks zones around their planets, where the surface temperature on the planet could be just right for liquid water. And every day we're finding smaller and smaller planets, the hard guys to find. We haven't yet found Earth 2.0, a planet that's exactly the size of the Earth and has the Earth's mass and is located at a distance from its star the same as the distance of the Earth from the Sun, a potentially habitable world. But I think we're really, really close. And when we do find it, when we can say, there, Earth 2.0, I think the game will be forever changed. People everywhere will suddenly want to know, does anybody live there? And can we go there? Of the 20 nearest stars around the Sun, we now know that there are at least 34 planetary systems. So within 12 light years of the Sun, we may find an ideal destination for the 100-year starship. But we, have so much to learn to prepare for this journey that we can't yet even say whether we should aim for a habitable world or one that's already inhabited with a biosphere that is alien to life on Earth. The search for extraterrestrial intelligence, SETI, will continue to explore worlds far beyond our local solar neighborhood. We'll use radio telescopes and optical telescopes, and we're looking for evidence of somebody else's technologies. In Northern California, the first 42 antennas of the Allen Telescope Array are being used to search all the known exoplanet systems, looking for engineered signals, for some pattern that nature can't produce. And our automated algorithms can easily detect humanity's most distant piece of technology. The Voyager 1 spacecraft is now leaving the solar system, and its signal takes 17 light hours to reach Earth. Today, our optical and radio telescopes can explore the millions of stars and their planets within 100 light years of Earth, looking for strong, deliberate signals. And tomorrow, international, larger telescopes, such as the Radio Square Kilometer Array or the Optical Extremely Large Telescope, will be able to look further for weaker signals, for more complex patterns, indicative perhaps of biology as well as technology. And participating in these searches and these voyages of exploration can have a profound impact on our home world. These enterprises hold up a mirror to all the people of Earth, encouraging us to see ourselves from an extraordinary new point of view, a mirror that can trivialize the differences among us, a mirror that inspires us to cooperate and collaborate on projects that will protect our own fragile island of life as we seek out others. The 100-year starship and SETI have the power to inspire our own generation and generations to come. International collaborations built within the EU Horizons 2020 program and based on such globally appealing and inspirational explorations can become the first 7 years of the next enlightenment. Thank you.
Thank you.